that we know?
Convolution?
Yes. One of the online people said convolution. Very close to the convolution, right? With a slight change there. But this is the cross correlation. We compute the inner product between F and all or every possible time shift of G. Why do we need to find the inner product between F with all the possible shifts of G, which is the received signal? Is it clear to everybody why we do that?
So they can be aligned up, right? So we can get like...
Right. Tell us if this matches this message or the other message. Example, if there is no questions. Any questions? All right. Let's say we have airport radar system that transmits the following signal. You see if we can detect any moving object there. It hits object, takes some time, it will come back. Then, so after that signal was sent, it hit airplane. And it's bouncing off, and we received the following signal. Look at the received signal. It collected some noise, came back. But obviously, it looks like our signal at some point. So if we calculate the cross correlation between these two signals, we find that where is the best match happens, the peak. That lets us know what is the difference in time between the start of this one and the start of the signal. Using that time difference and the speed of the signal, which is light speed, we can calculate the distance between the radar and the aircraft. All right, so we have signal, it's there, coming back. This is the sent one, this is the received one. So we will calculate the cross correlation between these two signals. And when we get the peak, we understand that's our signal bounced off the aircraft, and we got back to us. What we calculate is the inner product between F and the G. And we get psi. Look at the time axis. This is 1 to actually to negative 10 to negative 4. So it will be 0.001 when it started. And so we received the signal at this point. We got the peak at time -2. That's the delay, -2. We got the peak there. So that tells us the peak happened at time -0.2 milliseconds. So that's 2 times that, right? So we know that the delay is 2 milliseconds. Can we find how far the distance between the aircraft and the radar? Can you do that? Okay, do the math and tell me how far is that the aircraft from the airport. So what is the speed of light? Yeah, use the kilometer and tell me how far that in kilometers. So here just we find the inner product between F, the sent signal, and every possible delayed version of the received one. So we got this one, and this is the peak. So remember, this is the time, which we found is 0.2 milliseconds. That's the lag, 0.2 milliseconds. How close the aircraft from the airport? Consider the following. The signal goes in one trip and coming back, right? So consider that. What is it? 30 what? 30 kilometer, yes, exactly. Thank you. Because we need to divide by 2. Because this is the whole trip, you'll find like 60 kilometer. Because that's the signal go, hit the aircraft coming back. That's how long it takes. So how we find that? We find based on where's the peak happens by calculating the inner product between our original signal and every possible shifted version of the signal that we are receiving. So the peak happens at the lag time that you will need to calculate the distance. So it happens in a part of a second. All right, questions?